In this lesson, we're going to look at something called prime numbers. Now, in the previous lesson, we looked at factors. So factors are numbers that multiply to make a number or divide into a number. So we're going to look at factors for these two groups of numbers and how many they have. So if we look at 6, 6 has got 4 factors. 1, 2, 3, and 6 all divide into 6. 8 has got 4 factors. 1, 2, 4, and 8, they all divide into 8. I'm just doing this quite quickly. If you're not sure of factors, maybe watch the previous lesson. 12 has got 6 factors. 1, 2, 3, 4, 6, and 12. 20 has got 6 factors. 1, 2, 4, 5, 10, and 20. And 32 has got 7 factors, quite a lot there. So 1, 2, 4, 6, 8, 16, and 32. If you look at these numbers, 5, 7, 11, 19, and 23, then 5 has only got 2 factors, 1 and 5. 7 has only got 2 factors, 1 and 7. 11 has only got 2 factors, 1 and 11. And you can probably see a pattern happening here. 19 has only 2 factors, which is 1 and 19, and so does 23. So these numbers and all their factors have always got 1 as well. One of their factors is 1, so 1 times something, 1 times something, 1 times something. In fact, these numbers have got a special name. So there's a special name for numbers with only 2 factors. They're called prime numbers. So numbers that basically don't divide by anything apart from their self and 1. Now this brings up a kind of funny case. You might think, what is 1? Is 1 a prime number? Well, it doesn't have 2 separate factors. It would just have 1 times 1. So it would only have 1 factor. So in fact, 1 is not a prime number. Now, I'm going to quickly look at this idea up to 100. This is a thing called Eratosthenes' sieve. This is how he worked out all the prime numbers up to 100. He sieved out the ones that were not prime numbers, the ones that divided by other things apart from themselves and 1. And this is how he did it. He basically looked at 100 square, and there's obviously prime numbers further than 100, but I'm just going to start with this point. And he got rid of all the numbers that divided by 2. Kind of like what I'm going to do. So there's all the numbers that divide by 2, because they can't be prime numbers, because they would divide by more than just themselves and 1. The only one that's up here that is a prime number is 2. So I'm going to change that back to grey, if you like, because that's got 2 factors, 2 times 1. Now the other thing, I'm going to get rid of 1 because 1's not a prime number. It doesn't have 2 distinct factors, just as the same 1 times 1. And then what happened, he looked at things that divided by 3. So we'll get rid of 3. Things that divide by 3, that's the 3 times table basically. Except 3 is a prime number because it's 3 times 1, there's nothing else, so we'll bring 3 back in. What you'll find is we're getting rid of all the numbers that are not prime numbers, and we'll be left with all the ones that are. Now, I could get rid of numbers in the 4 times table, but they've already been blanked out with the 2 times table, so we don't need to do anything with that. But I will get rid of the 5 times table, so let's get rid of the 5 times table. Okay, that's all these numbers down here. These would get rid of in the 2 times table. But we'll keep 5 in, because 5 is a prime number. 5 times 1, nothing else divides into 5. 6 times table has been wiped out with the 3 times table. The 7 times table, okay, let's get rid of the things in the 7 times table. Okay. Except I'm going to keep 7 in, because 7 is a prime number. 7 times 1 makes 7, there's nothing else that divides into 7. The 8 times table has already been taken out by the 2 times table, and the 9 times table has already been taken out by the 3 times table, and the 10 has been taken out by the 2. So what's left here is in fact all the prime numbers. Now these prime numbers shouldn't be able to be divided by anything apart from themselves and 1. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there's 25 prime numbers that go up to 100. Okay, so that's a basic definition of prime numbers.